Hello everyone, I'm Pixel and I'm currently working on a video game in GameMaker Studio 1.4. Now, this is not the current version of GMS, but I'm reasonably certain a lot of this is compatible with Studio 2, and in either case, the point is not to give out a script for everyone to peruse, but to explain the whats and hows so you can make your own. GMS has support for 3D models. Sort of. It doesn't take any conventional model files, and to make your own 3D models you pretty much have to input them vertex by vertex, which is a painstaking process I only did twice before deciding to find a way to import them directly from Blender. A Blender exporter to GML exists, but it doesn't work in the current version of Blender, so I had to roll back to 2.79 and actually had both of them installed simultaneously for a long time, which wasn't helping with acclimatizing to 2.8. So I decided I needed to be able to import regular model files straight into the game. To facilitate this, I exported a basic 3D model into FBX, and it was gibberish. So that wouldn't do. Then I tried the same model as an OBJ file, and lo and behold, it was legible. Now at first this doesn't look very useful. Sure, it has all the model data, it has to, otherwise how would the format work, but can you reconstruct the 3D model from this? And if so, how hard is it? The first step is to understand what's in this file. All the lines are conveniently labelled, though a bunch of that information I didn't end up using at all. More on that later. Going from top to bottom, the file contains, first, information on where the file came from, which .blend file, and that was exported from Blender version 2.83.3. A material library. I'm not entirely sure what that does because I didn't need to look into it since I'm not doing anything with it. 3. The object name. Don't see the use for that for our purposes, but I'm sure somebody can do something with that. 4. A block of lines starting with V. This means that the lines in question contain vertex data. Every line defines one vertex with X, Y and Z coordinates. 5. A block of lines starting with VT. These are texture coordinates. They define every point on the UV map that is used by the model. 6. A block of lines starting with VN. These are normals. They define which direction a particular face is pointing. 7. The material name from within the material library. Likewise, useless to me. 8. A line starting with S. This defines whether or not smooth shading is enabled for this model. 9. A block of lines starting with F. These lines define faces. Even though the blocks of lines are not numbered, every one of them is assigned a number when importing, starting with 1 and increasing in integer steps. So the first V line is the first vertex, the second is the second vertex, etc. The F lines define faces by assigning vertex coordinates, UV coordinates and normals to them one by one. So first up, this particular model is just a basic cube, pre-unwrapped, and the only thing done to it was conversion to triangles because that's how I set up the importer. The first triangle defined in this uses vertices 2, 3 and 1 with the texture coordinates 1, 2 and 3 and all with normal 1 because it's flat, so why would it point elsewhere? From the normal index we can also glean that the second triangle of the set, to make the square that forms the left side of the cube, is the 7th. Not that it matters for importing, I just want to point that out. Right, now, knowing what all the lines do, we can start on the importer. Note, one thing that's very handy for string handling that GMS does not come with is an automated way to split strings. I wrote a script of my own for that, it's called string_split, and you will see rather a lot of it. I'm not going to explain exactly how it works because if you don't get to figure out anything for yourself, where's the fun? But what it does is, it splits the input string at a specified character and gives back whichever half you asked for. Very handy to have. And now you're going to need 4 two-dimensional arrays and a boolean. V, VT, VN, F, and S. Then, if you also want collision for your mesh, you can try a number of different things depending on how lazy you are. But for my purposes, a collision box was going to be sufficient. For this, I created 6 brand spanking new variables. I could probably have done it using only an array, but I don't care. It worked. These 6 variables are cbox_left, cbox_right, cbox_top, cbox_bottom, cbox_front, and you may have spotted the pattern cbox_back. Set these to values where you can be certain that the vertices will exceed them because those are meant to be overwritten as the OBJ is loaded. Open the OBJ as a text file since that's exactly what it is. Then go through the file on a while loop until you reach the end of the file. Now, for every line, check if it starts with V, VT, VN, F, or S. If it doesn't, ignore and move on. If it does, however, you save the individual components of the line into the corresponding arrays. So for instance, v10 is the x-coordinate of the first vertex, 1 is the y-coordinate, and so forth. When you reach S, check if the other half is off or on, and change the S boolean accordingly. This will be needed for rendering it later. If you want collision, then for vertex lines, you also compare the values against what's saved in the cbox underscore variables, and change those accordingly. Once the arrays are built, you go through the F array in a loop. The individual entries are still comprised of data you cannot work directly with, however, so you need to split those strings into their individual components along the slashes. First one is vertex, second is texture, third is normal. Once you have those numbers, you can plug them into the other arrays to get the values you need. At that point, it's just a question of rebuilding the model. This works differently in GMS 1.4 than it does in 2, so the specifics are probably fairly useless if you use the latter. All of those functions are obsolete, but here's how that looks anyway. The last step is to create the collision mask. This is a 2D thing, but it makes everything a lot easier because then you can use the much shorter built-in collision code for at least part of your calculations. All you need to do for that is calculate the width and height of the sprite based on the collision box values and bite off a chunk of the application surface. Doesn't matter what it looks like, it won't be drawn either way. And there you have it, a working OBJ importer for GameMaker Studio 1.4. With this, you can import any OBJ file during runtime, and it will only crash and burn some of the time. I've been Pixely Anosh. Have a great day.